All right, so today we're going to be talking about rational functions and their graphing and the vocab behind it. So first, rational means that you can be written as a fraction. Horizontal is a line that goes side to side like this. Vertical is our line that's going to be going up and down like this, so you have a vertical line. An asymptote is going to be an imaginary line that your graph approaches and stuff. So it says doesn't cross, but it can cross it. Just in the problems that we're going to be doing, they probably won't cross it very often. So you'll never cross a vertical line, but you could cross a horizontal line. So we're going to talk about the key features. So first of all, you say that a function is classified as continuous if you can like draw it without picking up your pencil. So that's when there's no breaks in the graph. So discontinuous is a break. There's a hole, there's an asymptote, something like that would be discontinuous. So there's a very specific definition for continuity, but you can just think of it as picking up your pencil. So your points of discontinuity depend on your x values here. So these are all the different types that you can have. So we can have a removable point. So that's just a hole in your graph right here. So that one point has just become a hole. And then you can have non-removable points, which are jumps or asymptotes. So right here, do you see how your graph, this would be a piecewise function. It jumps to another part. So that will only happen if you have two equations. And then a vertical asymptote here, we're going to learn about vertical asymptotes. But a vertical asymptote is a number that goes up and down, and it's always x equals that number. The domain is all possible x values. You read it from left to right, but you cannot include a hole or an asymptote. So you'd say it's all values except for this one or all values except for that one right there. Horizontal lines go this way, side to side. And your graph, as you go far left or far right, it's one that it actually approaches. It can cross it. So it does cross, but it's going to approach. So that's the better word, approach. So it's going to approach that line from left and right. So it could cross lots of times. The functions that we have here will eventually just approach it too, but most of them won't cross it, but it could cross it. And your vertical or your horizontal asymptotes are always y equals that number. Your range depends on your y values here. So range are your y values. And x-intercept is where it hits the x-axis. So like right here is called an x-intercept. This right here is your x-intercept. That's an x-intercept, an x-intercept, x-intercepts. So x-intercepts are always written as your number 0. Y-intercepts are written as 0y, or 0 number, and it's where it crosses your y-axis. Like right here is a y-intercept. Right here is a y-intercept. That's your only y-intercept right there. So now on the back of these notes, we're going to go ahead and we're going to just identify all these key features. So you're just going to look at the graph and we're going to talk about where everything happens. So first, the hole happens right here. So I'm going to say that's 4 negative a half. Okay, so that's your hole. A vertical asymptote is a line that goes up and down. So that happens at 2. Remember, it's always an x equals. And then horizontal asymptote is y equals. And it looks like our graph is approaching the line of 0 right here. So we're going to put y equals 0. Your domain excludes your vertical asymptote and your hole. So the way we write that is negative infinity to your smaller number, so negative a half, and then negative a half to the 2, and then 2 to infinity. So all of these values happen, negative infinity to negative a half to 2, and 2 to infinity. Your range depends on the y values here and then there. Oh wait, I've used the wrong y value. What is wrong with me? That answer is not right. It's the 2 and the 4. Oh lordy, go back and erase what I just said. Don't hate me. It's early morning that I'm trying to do this video. This one is the y value here. So we have negative a half to 0, and then 0 to infinity. All right, so this one right here, that looks like there's no holes, so I'm going to put none. Let's just go do around and do the holes. This one right here looks like there's no holes. This one, there's a hole right here, so I'm going to call that 0.31. And then there's no hole on this one. And then this one looks like it has a hole at negative 4, negative 2. Okay, let's do all my vertical asymptotes. Vertical asymptotes go up and down. So this looks like it does not approach the 0 line, so it's going to be x equals 0. Remember, these are all x equals. So this one has two numbers. It looks like it is at a negative 2 and a positive 3. So negative 2 and positive 3. And we always go from left to right when you're reading them. So this one right here is at negative 2. See down here, remember these are x equals. So put x equals. So this one looks like it's at the line to negative 2. And then this one is at the line of negative 5 and over here at 1. All right, let's do horizontal. Horizontals are y equals. So this graph looks like it's approaching the line of 2. This graph right here looks like it's approaching the line of 0. This one also approaching 0. This one is approaching 0. And this one looks like it's approaching this line right here of 2. So now remember domain. Domain excludes your vertical asymptote and there's no hole. So we just have to exclude 0. So you could say on the assignment for today, you're just going to say all x's except 0. All right, you're going to say all x's. So this would be all x's except -2 and 3. All x's except -2. So the way we write it in interval notation, though, is you just write negative infinity to your number to infinity. So this one has 2, so we have to do it like we did up here. So it's going to be negative infinity to -2, -2 to 3, and 3 to infinity. So negative infinity to -2, -2 to infinity. This only had one number, so I just had to put my 2 numbers there. So it always follows that form. So this is the same thing, negative infinity to -2, -2 to infinity. This one we have to exclude 2 again, so it's going to follow the patterns up here. So negative infinity to -5, -5 to 1, and then 1 to infinity. Range are all your y values. So it's your horizontal or the y value of your hole. So I just have to exclude 2. So it's the same pattern, but you put 2's where the 0's are. Negative infinity to 2, 2 to infinity. So this one I'm going to exclude 0. So negative infinity to 0, 0 to infinity. And then 0, oh shoot, there was a hole in this one. How'd you guys let me miss that one? So we need to exclude the value of 3 here. How many times do you think I can mess up on this video, you guys? 3 to infinity. So now I need to do 0 and 1 here. Oh, there's a hole down this other one too. You guys, I suck. Negative infinity to 0, 0 to 1, and then 1 to infinity. So this one down here really needs to go to -4. -4 to -2, and then -2 to infinity. So negative infinity to, let's see, -2 smaller, -2 to 0, 0 to infinity. And you can put u's, that means like and. So this one's none, so we just have to use the -2. I mean the +2. Oh, just kidding. Do you see how this crossed the line 2? So you don't even exclude 2 on this one. So we're just going to write negative infinity to infinity. So this is how I said you could cross the horizontal asymptote sometimes. That's an example of it.